Welcome back, students, to How to Manage Technology Projects by KP LAMA Education. This is the fourth video in the six-part video lecture series. In the previous video, we discussed ensuring you pick the right projects and why. So in today's lecture, we will discuss failed projects. So we'll be dissecting case studies that focus on failed projects. So, the first case study is the United States 2010 Decennial Census and the project Field Data Collection Automation, or FDCA. A bit of background. Every 10 years, the US carries out one of the biggest administrative tasks, the Decennial Census. Under Article 1, Section 2 of the US Constitution, every 10 years a census has to be conducted. Every census, people working for the government have to go to every address and record the data on paper. After this, all the data had to be put onto a computer so it could be processed and saved. One reason for the reform was cost, as from the census in 1990 to the census in 2000, the total cost doubled, and experts anticipated that the cost would reach $12 billion. The other reason was that the exponential growth in the demographic data and the old pen and paper method was just not designed to cope with this growing scale. Now the problem. Associate Director and Chief Operating Officer Preston J. Waite was in charge of the 2010 census, and he came up with a reform to convert the whole pen and paper system to handheld devices so that it was in digital format. By using computers to manage the census data, it would save a lot of time and money on the recording of the data and would make the data mining process more accurate. Between 2001 and 2004, the US Census Bureau was working on the overall business, logical and physical architecture of the system. The most important part of the program was the Field Data Collection Automation Project, the FDCA. The FDCA included the deployment of the handheld devices and the system that would run on them. The project was to be carried out in-house by Census Bureau's Technologies Management Office. The cost of the project was estimated to be around $800 million and have the initial field testing in 2004 and full testing in 2006. Here is the time scale, the timeline of the project, the projected timeline of the project. So, in 2001, J. Waite is appointed Associate Director for the Decennial Census. In 2001, Waite decides that handheld computing devices will be used for address canvassing and NRFU activities. The process of redesigning census processes to leverage technology is initiated. From 2002 to 2003, based on commercially available systems, an in-house prototype is created by the Census Bureau's Technologies Management Office. In February 2004, prototype is tested during initial field testing. Significant problems are identified, including the inability to handle the large amounts of data being processed, system freezes, data transmission problems, memory overload, and difficulties with mapping features. Following a review, the Census Bureau determines that it lacks the necessary technical capabilities or management resources to create a fully functional system. 4th of March 2004. The MITRE Corporation, an independent not-for-profit technical consultant, is engaged to prepare an independent assessment on the feasibility of using handheld devices. 28th of July 2004. Based on research and observations of the prototype and field testing, MITRE completes an independent assessment of the use of handheld computers for the 2010 Decennial Census. Report indicated handheld computing is feasible, but significant risks exist. From July till October 2004, MITRE assists the Census Bureau in creating an FDCA statement of work for use in tendering. MITRE also develops plans and procedures for an FDCA Project Management Office, a PMO. January 2005. In part, due to slow progress, the FDCA project is reorganised. Responsibility for the FDCA is transferred from the Field Directorate to the Decennial Census Directorate. A new project manager assigned, and a project management office PMO is established. January 2005 also. MITRE's support to the FDCA programme is cancelled after the new project manager is appointed. February 2005. MITRE is re-engaged but only to prepare an independent cost estimates for the FDCA project. February 2005. The Census Bureau begins initial information exchange with potential suppliers. April till May 2005. Pre-solicitation notice and draft solicitation paperwork are published. June 2005. The final request for proposal RFP is published. From May 2005 to January 2006, logical and physical architectures for the FDCA system are developed along with initial project management plans, risk management, communication plans, etc. From September 2005 to January 2006, qualified interested parties work with the Census Bureau to develop prototypes of the proposed system as part of the bidder evaluation process. 30th of March 2006. $595 million contract is signed with Harris Corp of Melbourne, Florida to supply 525,000 devices and develop the software. Work begins on detailed requirements analysis. March 2007. Harris reports previously established milestones and budgets were at risk due to the unanticipated number of actual requirements emerging from detailed requirements decomposition. In response, Census Bureau re-engages MITRE and requests they perform a red team analysis of the FDCA programme. April 2007. Address canvassing, dress rehearsal shows that the devices suffer from performance, data transmission and stability problems. Problems not dissimilar to those encountered during the 2004 testing. In addition, the Bureau determines that the system does not fully meet its functional needs. April 2007. MITRE is asked to assess the functionality of the devices and the performance. 6th of June 2007. Red Team report is published. Report establishes that FDCA is at significant risk of cost and schedule overruns and omission of essential requirements unless major changes are made quickly. Report firmly establishes that problems are the fault of the government and not Harris. 29th of November 2007. MITRE meets with Waite and his superior Census Bureau Deputy Director to review status. Meeting notes are leaked, revealing that there is no integrated plan. Communications have broken down, parties are unsure of the requirements, and that on the Bureau's side the project lacks a leader with the experience, stature or passion to make the FDCA successful. 16th of January 2008. The Bureau refocuses themselves and Harris is provided with a list of 400 new or changed requirements for the handheld devices. 6th of February 2008. Census Bureau Director steps in and forms the FDCA Risk Reduction Task Force. The task force identifies mitigation strategies and ultimately recommends handheld devices be dropped from the NRFU and that work be started on the design of systems needed to support a paper-based NRFU. 5th of March 2008. Following a review, the Government Accountability Office designates the FDCA project as a being at high risk of failure. 3rd of April 2008. The US House of Representatives is informed of the failure and the Bureau's recommendation that paper-based non-response follow-up be conducted. An additional $3 billion in funding is requested. 15th of April 2008. Waite is replaced by Arnold Jackson, who instigates regular meetings between stakeholders and arranges for Harris and Census staff to collocate into a single office space to improve communications on the remaining parts of the project. Address canvassing. The 23rd of April 2008. Waite retires from the Census Bureau. Now, let's highlight the cause of the failures. So, apart from the problems that MITRE's meeting showed, there were two main project management issues. The first is the failure of establishing good communication between the stakeholders and the project team. The other one was that the Bureau could not stabilise a firm requirements baseline. Additionally to the project management failures, a question arises. Why did the Bureau not see all the warning signs. The tests obviously showed that there were real problems. All the warnings that came up during the process later contributed to the failure of the project. Now, that was a 7-year project that consumed billions of dollars and ultimately failed due to the fact that 1. There was a severe lack in communication. 2. There was a severe lack of management. And 3. There was a severe lack of understanding the relative project processes to understand what the project resources required. So, the next case study, the NMCI experience and lessons learned. A bit of background. The Navy Marine Corps intranet, the NMCI, had been created to centralise the computer system that the US Navy used. The plan was to link 360,000 computers together and create a secure connection upon which video, sound and data could be shared. The $8.8 billion performance-based project was awarded to EDS. The company was responsible for providing all the hardware, software, operations, training, maintenance and system upgrades. User surveys were carried out regularly, and if the satisfaction percentage was high enough, EDS got paid. Meaning, if the Navy and Marine employees did not like the system that EDS implemented, they would not have got paid. It showed the EDS done their best to make the job as good as possible. Now, the problem. One of the early problems experienced by the program was a result of the fact that neither the Navy nor EDS fully understood the magnitude of the problem of the project. Many of the technical requirements only surfaced after the contract was awarded. In the year 2000, GAO wrote a report that mentioned that the Navy never completed a business case analysis. The rate that EDS could produce the seats was lower than planned due to the fact that EDS was understaffed for a project as big as this. The Marine Corps were supposed to get 30 seats per day, but after the first 90 days they only got 568. EDS lost $334 million in the first quarter of 2003 and $316 million in the first 6 months of 2004. The transmission for the legacy systems to NMCI was another big problem. The Navy wanted to have 500 NMCI accredited programs. This was recognised by both the Navy and the EDS. What they did not count on, however, was the number of these applications was round about 100,000. After realising this, they tried to reduce the number of these applications to 3,000, and as of 2004, they had 31,000. Slightly higher than 3,000. Another major problem was security for the NMCI. With all the legacy systems, the staff had to know which ports to use, and they also needed to know what possible cyber attacks to expect. The current situation. The NMCI is not a failed project in all aspects. The Navy did get a working, secure enterprise network. The system has had very few intrusions over the years, and it now supports 650,000 seats worldwide. However, the project was a big failure for EDS. They lost around $3 billion, and they will never recuperate those lost funds. According to EDS, it is now providing a constant flow of money, but it is unlikely to ever turn a profit for them. Another reason this was a failed project was that sending large files, as well as zip files, is not supported because of the security measures EDS equipped on the system. Now, what are the lessons learned from this? A centralised system like the NMCI might not be the best idea for a big organisation like the Navy. With the constant deployment of personnel on different missions, in different international areas, also including each base that the Navy has worldwide. It just was not possible for the programme to suit every personnel's needs. The NMCI might have been too big a project for just one vendor. The EDS had little to no chance to actually meet the requirements of the system. In my opinion, the Navy should have just went for a more regional approach with multiple vendors. So, two very different case studies. One focused on ensuring you have all your different development processes in place and understanding the information that they portray ultimately affects the outcome of the project. Whereas the other one is simply down to lack of understanding the project magnitude and having the manpower to actually complete a project of a very large scale. Both highlight, however, a severe lack in communication and management. So, but this will mark the end of the lecture, and it will be the start of your first tutorial. You will find the tutorial on the KP LAMA website, alongside the lecture video. Any questions you have in the forum, as per usual. Any particular questions, email us, and we'll get back to you as soon as possible. But once you've completed the tutorial, there will be 5 questions per case study, 5 for the Navy case study and 5 questions for the census case study. So once you've completed all 10 questions, please submit those your answers to the KP LAMA email provided in the link on the website, in Word or PDF if you can, and we will mark them and have them returned to you as soon as possible with some feedback before the next tutorial. So join us next time for our 5th lecture, which will focus on successful projects, and we'll focus on case studies that pertain around that. So until our next video, goodbye.